We are going to discuss about the collection of the crude drugs, right? Because ultimately we are doing the cultivation of the medicinal plant so that we can collect the good quality of crude drugs which is going to bear into that medicinal plants. It may be any part of the medicinal plant, right? So as we know that these are the primary types of drugs, right? So care has to be taken care. Here you can see that collection is the most important steps which comes after cultivation. After cultivation, the first thing or first step, that is collection. The time of collection is very very important, because ultimately our goal is to get the good quantity of and good quality of chemical constituents supposed to be there in our crude drugs. The drugs are collected from wild and cultivated plant. That has to be collected. It may be from sometimes wild source or forest. Directly wild grown plant we have to target, and we have to collect the good quality of crude drugs. And cultivated means when we are cultivating the medicinal plant by the taking care about all the factor affecting, then we are going to collect those kinds of crude drugs. Task for cultivation depends on the collector, whether he is skilled or unskilled labor, right? So that's what the skill, it has to be there. The person who has involved in the cultivation, he is supposed to have the scientific knowledge that the in which stage of the medicinal plant the plant will bear the proper types of crude drugs which will be having the good quality of and good quantity of chemical constituents. The drugs should be collected when they contain maximum amount of constituents. That's what, right? With the time of collection, here the matter is the time, right? At what stage we are going to collect, so that the drug will be having the maximum or good quantity, or a very good quantity of the chemical constituents which we know, which we want ultimately for. And that is only the intention behind us to cultivation of the medicinal plants. The next one, the season at which the drug is collected is important, as amount of active constituents, it will be there throughout a year. And what season the the type of chemical constituents it is there in maximum quantity. For example, rhubarb. Rhubarb is one of the glycosidal containing crude drugs. It is collected only in summer season, because anthraquinone derivatives level is more in summer season and less in the winter season, right? When we are going to collect the rhubarb in winter season, we are not going to get the good quantity of the what do you call anthraquinone glycosides, right? So that's what the collection of the rhubarb, the the drug, the part of the plant, that has to be done only in the summer season, where the day length is more, right? Leaves are generally collected just before the flowering season, right? Whenever we are collecting the leaf, like for example senna leaf or vinca leaf or any other types of eucalyptus leaf, so we need to see the medicinal plant, that whether they are going to have the flowering season. Now they are going to bear the flowering season. Before that we are going to collect the those kinds of leaves. Example, here you can see vashaka and a digitalis leaf. They contain maximum constituents before the plant bears the flower. When we want the maximum quantity of the constituents in that particular leaf, like digitalis, in digitalis digitoxin and digitogenin, it will be there, that is act as a cardiac glycoside. So it will be there in the maximum quantity when we are going to collect them before they reach to the flowering stage. That's what. The next example, flowers are collected before they expand fully. Example, clove and saffron flower, like clove buds, right? That has to be collected before they will reach to the expand fully, right? Here you can see they are collecting the flowers. So in that stage they are collecting before they expand fully. The next example, the underground organs like tubers and roots are collected before plant cell die, right? Plant cells, that aerial part of the plant cells, if they are going to die, or the leaves will become dull, at that stage it is indication that the inside or underground whatever the rhizomes and the roots and tubers are there, that has reached to their fully maturity stage. Examples are licorice root and Rauwolfia root, right? So licorice is glycosides and Rauwolfia is alkaloid. So here, what it is the indication that whatever the tubers and roots you are going to get, they will be having very good quantity of chemical constituents. Some fruits are collected after they fully maturity, full mature, and some are collected when they are ripe, right? Sometimes we have to wait for the ripen fruit only, it will be having good quantity of chemical constituents. And sometimes we have to see their maturity level, it has reached fully mature, then only we are going to collect, right? So these are the different examples. Here you can see the example of bark. Bark are usually collected during spring season, as they are easy to separate from the wood during this season, right? So here you can see that how they are collecting the bark. They have detached from the wood, because there will be the cambium cells, right? So the activity of cambium, it is to grow towards the bark and towards the wood. So the cambium, if it is there in the such a stage, so that we can collect the bark easily from the wood, it will be detachable easily, like ashoka bark, cinchona bark, and kurchi bark example, right? So these are the example of the bark. So at that particular spring season, we have to select for the collection of those kind of bark. The unorganized drug, for example dried latex, dried juice, or different types of latex, right? Or different types of extract, that has to be collected as soon as the OJs out, right? The OJs, that is the one of the indication that when you will do the penetration onto the particular incision at the particular branch and the stem, the OJs will come out. So that will be the indication that the unorganized crude drugs, it is having the chemical constants which we want. Example, resin, latex, and gum, right? In resin there is a benzoin, asafoetida, right? And the different types of other incisions which we are making them. Then latex, like opium latex, we need to penetrate the capsule of the opium with the thin metallic needle up to 2 mm depth, then the ojes will come out. And if they are coming in maximum concentration and good quality, it will be considered that they will be having very good quantity of the chemical constants like morphine, codeine, heroin, and berberine. Then gums, different types of gums are there, right? In carbohydrate containing crude drugs, also acacia, tragacan, then all those things, right? So these are the, say, after collecting of the crude drug, the major task it is that uh, what you call drying of the crude drugs. So at what how much we have to dry, how much moisture content has to be removed to avoid the fungal growth and other types of growth, that we need to consider. Before marketing a crude drug, it is necessary to process it properly, so as to preserve it properly and acquire better pharmaceutical intelligence, right? That's what the major task is, to how to preserve, right? If you'll consider the simple pickle which you are preparing into your kitchen, for mango pickle or some other types of pickle, amla pickle, so we are adding the preservative there, like in the form of salt, turmeric, or oil, right? So that that pickle we can use it for the long time. So here, when it comes to the crude drugs which we are going to use for therapeutic purpose, it has to be preserved properly, and so that without any contamination we can store them for the long time. That's what the removal of moisture content, it is very much essential. And to acquire the better pharmaceutical ingredient and the pharmaceutical efficacy, right? That's what these are important. Drying consists of removal of sufficient moisture, so as to improve quality, make it resistance to microorganisms, and inhibit enzymatic reactions, right? These three things we need to consider, so that we can improve the quality during the storage also, right? Because if the more moisture will be there, the chances of more microbial attack, more fungal attack will be there. That's what we need to remove the moisture at the proper quantity and make it resistance to microorganisms. Make it means make the drug which you are going to preserve or which you are going to store, that should itself having the capability to resist the microorganism. Even though microorganism wants to attack or contaminate your crude drugs, they will be having such kinds of quality so that they can defend themselves during the storage and inhibit enzymatic reaction. There is a chances that the drug which you are storing in your warehouse or in your store, it will be having their own enzymatic reactions, the levorotatory or dextrorotatory, the changing of the chemical constants into the different form, right? If the drug caryophyllene, it is very good for the health, right? It is useful as a medicinal property. But if the caryophyllene will change its form or with the enzymatic reaction, it is going to be toxic. So that's what that kind of changes also, or that kind of reaction we need to inhibit or we need to stop. So when it comes to the drying, the different task, how we are going to select for the drying method depend on the different types of crude drugs. So here they have given the drying methods. So the first one, the drying is divided in two major category. First one is the natural drying and the second one is the artificial drying. When it comes to the natural drying, direct sun drying, we can subject the drug into the direct sunlight so that with the sunlight temperature they will be able to remove their moisture content. But when it comes to the artificial drying, we are using the different types of equipments and instrument, right? Tray dryer, vacuum dryer, and spray dryers, right? So let us discuss one by one. Natural drying. In natural drying, as we discussed, the sun drying. In sun drying, it may be either direct sun drying or in the shade drying. Sometimes, if you are keeping the drug in your room, there also sunlight comes, but not directly, right? Sunlights come by the reflection from the outside, and it will come to your room, and there also they are going to maintain the room temperature or whatever the temperature, and the drug is started drying. And direct sun drying means direct sun in either in the terrace of the building or into the floor. We are going to have the mat, and there we are going to display our crude drugs which we have collected. The next one, if the natural color of the drug, for example, digitalis, clove, senna leaf, and the volatile principle of the drug like peppermint oil, right, are to be retained, drying in the shade is preferred. Why? Because the chemical constituents present in digitalis, clove oil, or in clove, or in senna, or even in the peppermint, mentha piperita, their their volatile principle, right? The volatile is the one of the chemical constants which will having the property, whenever it will expose to the room temperature, it will evaporate like a petrol or diesel or some other types of highly evaporable oil like petroleum ether, right? So it will evaporate. So if you will subject these kinds of drug in the natural drying or in the direct sun drying, what will happen? The main chemical constant which we want, and we for what that we have cultivated this medicinal plant, these chemical constants will evaporate, and afterwards you are not going to get the therapeutic value from those kinds of drug. That's what the said drying it is preferred for this kind of drug. We have to dry into inside the room or where the direct sunlight is not coming. If the contents of the drug are quite stable to the temperature and the sunlight, the drugs can be dried directly under sun. For example, gum acacia, different types of seeds like nux vomica seeds, and the different types of fruits like amla fruit, right? So these kinds of drugs can be subject for drying in directly sunlight because they are having the chemical constants which will not be evaporate. So let us discuss the artificial drying let one by one. There are three types of artificial drying. The first one is the tray dryers, right? Here you in the image you can see the different types of trays. It is there. In those trays, we are going to insert the crude drugs, and we are going to maintain the regulate the temperature so that at the desired temperature we can dry those kinds of drugs. The drug which do not contain volatile oil and are quite stable to heat are dried in tray dryer, right? So where they will not contain volatile oil, here we need to take care about, we need to have the knowledge about the drug whether it is having the volatile principle or not. then only we can subject for tray dryer. In this process, hot air of a desired temperature is circulated through the dryer, and this facilitate the removal of water content of the drug or from the drug, right? The desired temperature can be maintained with the hot air, right? It's like a oven only, right? So hot air, it will be uniformly circulating throughout the inside chambers wherever the drug is displayed into the different trays, and the removal of water content will take place. Drugs dried by this method are belladonna roots, cinchona bark, tea leaves, and gums. These are the four examples which we can subject for drying under the tray dryers. Coming to the next one, vacuum dryers. As the name indicate, vacuum we are going to supply. The water is removed by applying vacuum, right? The drugs which are sensitive to higher temperature are dried by this process. For example, digitalis leaf. Here you can see that steam or water jacket. It is there. They have made this in such a way, and the condenser it is fixed in the another side where water inlet and water outlet is there, and the connection to vacuum pump. Here vacuum pump will be connected, so vacuum will be supplied here, right? And it will go throughout the inside chambers where the drug it is displayed, and with the vacuum it is going to dry. The drug is dry, and the condense the receiver, right? Condensate receivers. So like that, with the vacuum we are going to remove the water content. The third one in artificial dryer, that is the spray dryers, right? Some drugs are highly sensitive to the atmospheric condition and also to the temperature of the vacuum drying, are dried by the spray drying method, right? Spray drying. So here, as the name indicates, spray we are going to do, right? This technique is followed for the quick drying of economically important plant and animal constituents rather than the crude drugs. So sometimes the constituents which we are getting it from the animal and plant source, that we are going to dry, right? And the example of spray drying is the papaya latex, resin and tannin. These papaya latex means it will be in the liquid form. Then after making the incision into the papaya fruit, whatever the latex it is come out and getting solidify onto the surface of the papaya fruit, that we are scraping out and we are collecting. So such types of latex we cannot subject for the vacuum dryer or some other types of drying. Spray dryer, here you can see that air filters, the heater will be there, and that will be connected with the dryer, and here we are going to feed, right? Then ultimately the cyclone will be there, the air is going to out here, air going to in, and the dried solid particle we are going to get here, right? Spray by spraying, right? So these kinds of drug which is economically important, we are going. Ultimately, after drying, the major task it is coming, that is the storage of crude drug. How we are going to store and where we are going to store. These two things are very important when it comes to the storage condition. Preservation of crude drugs needs sound knowledge of their physical and chemical property, right? Physical like solubility, their extractive value, ash value, optical rotation, refractive index, specific gravity, all those property we need to know. And the chemical property, whether they are having lone electron releasing group, electron withdrawing group, lone pair of electron, how they are donating or how they are receiving, all those types of their uh, chemical property we need to know about the drug, then only we are going to store them according to that. If the drugs are improperly stored, the quality can be affected, of course. If the drug where the moistures are there, where the sunlights are coming directly, where the rodent, if it is not rodent proof, the rat, mice and all those insects are roaming over there, so definitely they are going to lose their quality and even the quantity of the chemical constants. All the drugs should be preserved in well closed and airtight containers. Of course, well closed in the sense there should not be the air passes supposed to be there, and the it should be rodent proof. It should be the light proof. Depend on the drug, we need to understand how we are going to have the container. They should be stored in premises which are waterproof, fireproof, and also rodent proof, right? Of course waterproof, because we have seen that drying is how much important. If the moisture content will be more, or it will not removed properly, or if it is there, even after removal of moisture, if you are storing it there, moisture zone it is there, and they are going to attract the moisture, and water falls are there definitely, and fire, right, if it is that fire or some fire area is there, so it should be having the fireproof, and even the rodent proof. The rodent is the sense rat, mice, rabbit, insect, lizard, cockroaches, and different types of rodent which can be attacking your crude drug, right. Here, many drugs absorb moisture during their storage and become susceptible to microbial growth, right. From the atmosphere, the drug it is having capability to absorb the moisture, of course, and when moisture will come into drug, definitely they will attract the fungus, they'll attract the other types of microorganism, and when the microbial contamination will start, it will be difficult to control them. That's what, right. Moisture can be affected the quality of and the quantity of drug, both, right. Moisture also facilitates the enzymatic reaction, for example digitalis leaf. Enzymatic reaction, if it will take place, in the last slide we have discussed that the digitoxin and digitoxygenin, these are the constituents which will be there in the digitalis leaf, which is acting as a cardiac glycoside. If they will take place the enzymatic reaction, they are going to change their form, and instead of giving the the cardiac activity, they may give the some other types of harmful effect. That's what. Moisture also leads to the growth of molds. Example, gelatin root and ergot alkaloid. These two example, they will have, if they will be having the moisture or water content, they will lead to the growth of molds, which is again harmful. Radiation due to the direct sunlight also cause the destruction of active chemical constituents, which is ultimately our goal. So direct sunlight, we have discussed the example of volatile oil, right? If you will expose the drug like clove and eucalyptus leaf into the direct sunlight, they are going to lose their chemical constants, or the volatile oil principle, it is going to evaporate, and ultimately you are not going to get. Atmospheric oxygen also act as a destructive agent. See, oxygen, air, to several drugs. Hence, drugs are completely in well stored container. The air is in the container are replaced by the inert gas also, like nitrogen. In examples of shark liver oil and papain enzyme, which we are getting from carica papaya, right. So atmospheric oxygen, it is destructive agent, it is telling, right. The atmospheric oxygen should not come into the contact of the drug, in the case of shark liver oil and papain enzyme, right. That's what, it has to be stored airtight container, and by replacing by the inert gas like nitrogen has to be there inside, so that it will be preserved. Temperature is also very important factor in preservation of drugs, as it is accelerates the several chemical reactions leading to the decomposition of chemical constituents. Like temperature also we need to regulate or maintain during the storage, right. Important factor in preservation, because they are going to lead the chemical reactions which is cause the decomposition of constituents, which is not supposed to be. Hence, most of the drugs are stored at low temperature, right? We need to store them into the low temperature. We have to maintain the temperature during the storage. It is essential to preserve the drugs against the insects or mold attack. Of course, it is because insects, if small microorganisms are doing the harm effect, the insect obviously they are going to have the effect and molds that we need to preserve. This can be achieved by giving treatment of fumigant, right? The fungicides, that fumigants we have to spray over there, and time to time we need to observe the drugs which we have stored properly, whether any kinds of attack it is there or not. The common fumigants used for storage of crude drugs are methyl bromide, carbon disulfide, and hydrocyanic acid. These types of fumigants we can use for the attack of the different types of insects or microbes, right. So these are the drugs different examples of drug we have discussed here, which is very useful for the storage of crude drug.